previous video we have seen about the theoretical portion of socket and spigot quarter joint, and we have seen various application and various construction details and notations used for design of socket and spigot quarter joint in previous video. So in this video we are going to see the design procedure of socket and spigot quarter joint. So let us start with the design procedure of socket and spigot quarter joint. Please see, if you see my cursor, what is the first step while designing socket and spigot quarter joint is, that is failure of the rods in tension. See guys, we need to check the rods under tensile failure. Okay, that is the first step of designing of socket and spigot quarter joint. So the rods may fail in tension due to the tensile load P. Let us see, your rods is going to fail in tensile load, and we are going to consider that the load due to P. Okay, then we know that area resisting tearing is given pi by 4 into d square. We know that rod has circular cross section. So what is the area of circle? It is given by pi by 4 into d square. So therefore tearing strength of rods is equals to pi by 4 into d square into sigma t. We need to equate it with the sigma t, and after equating this load, this relation with load P, then what we get, please see, P is equals to pi by 4 into d square into sigma t. So what we done, we have equate this equation, that is pi by 4 into d square into sigma t with load P. We have put in the same formula here, that is P is equals to pi by 4 into d square into sigma t, and from this equation diameter of rods d may be determined. See guys, from this equation we have this value, again we have this value. So this is what, this is given value, that is permissible tensile stress, which is given in the numerical, or we need to select it from design data book for the given material. So after equating this equation with load P, we are going to find out the diameter of rods d from this relation. Okay, this is the first step. So in first step, that is failure of rods in tension, by this first step we are get one dimension of quarter joint, that is diameter of rod. Okay, which is denoted by small d. Then what next? Please see, this is the second step of design of socket and spigot quarter joint. Please see, second step is what? Failure of spigot in tension across the weakest section or slot. See guys, what is the second step? That is, we need to check failure of spigot in tension. Okay, because of tensile load, failure of spigot is happened there, and we need to check that across the weakest section or slot. So in this diagram, if you see this diagram, you can see this is what T, this is thickness. Okay, and this is D2. Okay, this is D2. So guys, please see, since the weakest section of the spigot is that section which has a slot in it for the Cotter, as shown in figure. See guys, so we have mentioned in this step what? Failure of spigot in tension across the weakest section. See guys, now we need to identify what is the weakest section first. So where is the weakest section? The section in which a slot is provided. Okay, a slot is provided for the uh, spigot and socket. Okay, so that is the weakest section as shown in figure. So this is slot, this is slot is provided. Okay, that section has a slot in it for the Cotter. So guys, this we need to check. See guys, as it is written here, since the weakest section of the spigot is that, which is the weakest section? The section which has a slot in it for the Cotter. Okay, so this is the weakest section. Then that is why area resisting tearing of the spigot across the slot is equals to pi by 4 into d2 square minus d2 into t. See guys, what it is? Pi by 4 into d2 square minus d2 into t. And tearing strength of the spigot across the slot is pi by 4 into d2 square minus d2 into t into sigma t, because as we are going to check it for tensile failure, so that is why we are going to use this sigma t over here. Then equating this to load P, we have, if we are equating this equation, that is pi by 4 into d2 square in minus d2 into t into sigma t with the load P, what we get? P is equals to pi by 4 into d2 square minus d2 into d2 by 4 into sigma t. Okay, now I have mentioned d2 by 4. Okay, this instead of this t, I have written d2 by 4. So don't get confused over here. See guys, I have mentioned one note here. What, why I am doing so? Please see. In actual practice, the thickness of the Cotter T, okay, the thickness of the Cotter small t is usually taken as d2 by 4. See guys, in actual practice, the thickness of the Cotter T, which thickness of Cotter is denoted by small t, is usually taken as d2 by 4. So what is the value for thickness of Cotter small t? That is small t is equals to d2 by 4. That is why I have written over here, that is, instead of writing t, I have written the d2 by 4 into sigma t. Okay, So from this equation, the diameter of spigot or inside diameter of socket, that is D2. See guys, from this equation, the diameter of spigot or inside diameter of socket, that is D2, may be determined. So by considering the spigot failure under weakest section in tensile failure, we are going to get one dimension of socket and spigot quarter joint, that is diameter of spigot or inside diameter of socket, that is D2. Okay, that should be determined. So what next, please see. Now this is the third step, that is third step is failure of the spigot in crushing. Now see guys, we need to check spigot for crushing failure. So how it is, please see. We know that the area resist crushing of a rod. See guys, we know that the area resist crushing of a rod, that is spigot end or Cotter, is equals to d2 into t. It is given by d2 into t. Therefore crushing strength is equals to d2 into t into sigma c, because we are going to check spigot failure under crushing stress. So that is why we are written here d2 into t into sigma c. Now equating this load, equating this to load p, we have, if we equate this relation, that is d2 into t into sigma c with the load p, what we left with, please see, p is equals to d2 into t into sigma c. So from this equation, the induced crushing stress may be checked. See guys, now what we are doing, we are going to check the spigot for the crushing failure. So as we know that this one sigma c that we have given in the numerical, or we need to select from design data book, so that is a permissible or allowable crushing stress. Okay, so we need to check that whatever will be the value of sigma c, from this relation we need to calculate the value of sigma c, and if this calculated sigma c value means induced crushing stress value is less than your permissible or allowable crushing stress value, then it means that your design is safe. Okay, that we know very well. So in this relation, we need to calculate this value of sigma c, which is induced crushing stress in spigot, and if your value of sigma c is less than the permissible value of crushing stress given for the material, or if it is less than the allowable value of crushing stress, then your design will be safe. Okay, so by this we need to calculate, in this step we need to calculate the sigma c, and we need to check whether it is more or less than permissible. Okay, the next step is step number 4 is, that is failure of socket in tension across the slot. See guys, what failure of socket in tension across the slot, we seen failure of spigot in tension. Now we get to see the failure of socket in tension across the slot. Now we know that the resisting area of the socket across the slot, as shown in figure. See guys, this is the resisting area of the uh, socket across the slot. See, this is slot is provided over here, and this is the uh, socket portion, and this is D2 and this is D1. Now for this we have relation pi by 4 into D1 square minus D2 square minus D1 minus D2 into T. Therefore tearing strength of socket across the slot is given pi by 4 into D1 square minus D2 square minus D1 minus D2 into T into sigma T. Because why sigma T? Because we need to check it for tensile failure. And after equating this to load P, after equating this relation with load P, we have P is equals to pi by 4 into D1 square minus D2 square minus D1 minus D2 into T into sigma T. From this equation, outside diameter of socket, that is D1. See guys, from this equation, outside diameter of the socket, here you can see in this figure, that is D1, this is the outside diameter of socket. From this equation, the outside diameter of socket D1 may be determined. Okay, by this step number 4, we got one dimension of socket and spigot cotter joint, that is D1. Okay, which is equals to outside diameter of socket. Then next step number 5 is failure of cotter in shear. See guys, now we need to check cotter for shear failure. Okay, so see guys, considering the failure of cotter in shear as shown in figure, since the cotter is in double shear, therefore shearing area of the cotter is given twice B into T. See guys, let me take you to the figure diagram. So this is cotter, you can see this is tapered in nature from top end to bottom end, that we have seen in previous video, and this is what, this is the cotter width, that it is given thickness and B. Okay, now see guys, if your cotter is subjected to shear failure, then failure maybe look like this, look like it. Okay, see guys, if you see, if you try to understand it, okay, this is because of shear failure. This is B, this is B, and this is thickness, and this is also B. This is rectangular cross section of this tapered pin. Now, so for that, it is given one relation twice b into t. Why twice b? Because why it is I have mentioned that t, because rectangular, it is rectangular section, okay. But rectangular section, that is simply b into t, that is width into thickness. But your quarter is subject to double shear. See guys, here I have mentioned double shear. That is why I have written here twice b into t. And shearing strength of the quarter is twice b into t into tau. Why tau? Because we are going to check it for shear failure. That is why tau is there. Tau is representing your shear stress. Equating this to load P, we have, if you equate this relation with load P, then what we left with, P is equals to twice B into T into tau. See guys. So from this equation, width of quarter B is determined. See guys, from by this equation, width of quarter B, this B stands for width of quarter, that should be determined. Okay. So by step number 5, that is by considering quarter under shear failure, we get to know about the dimension of quarter joint, that is width of quarter. Okay. The next is step number 6 is failure of the socket collar in crushing. See guys, we need to check failure of socket collar in crushing. Now considering the failure of socket collar in crushing as shown in figure, okay, we know that area that resists crushing of socket collar, which is given d2, sorry, d4 minus d2 into t. See guys here. So d4 is the diameter, the d2 is again one diameter, and this is slot, and this is thickness of quarter. Please see. And crushing strength is equal to d4 minus d2 into t into sigma c. Okay. So equating this to load P, we have P is equals to d4 minus d2 into t into sigma c. By this equation, we can easily get diameter of socket collar, that is d4 may be obtained. See guys, from this equation, the diameter of socket collar, that is d4. This d4 is diameter of socket collar may be obtained. So by this step number 6, that is failure of socket collar in crushing, we can easily get this diameter of socket collar d4. Okay. Then next is step number 7. It is failure of socket end in shearing. See guys, failure of socket end in shearing. So since the socket end is in double shear, see guys, since the socket end is in double shear, therefore area that resists shearing of socket collar is equals to twice of d4 minus d2 into c, and shearing strength of collar is equals to twice of d4 minus d2 into c into tau. Why twice? Why 2? Because it is subjected to double shear. So equating this to load P, we have P is equals to twice of D2, sorry, D4 minus D2 into C into tau. From this equation, the thickness of socket collar C may be given. See guys, C denotes thickness of socket collar. So by step number 7, that is failure of socket under shearing, socket end under shearing, we get this dimension C, which is thickness of socket collar. The next is failure of rod end in shear. See guys, failure of rod end in shear. Since the rod end is in double shear, therefore the area resisting shear of the rod end is equals to twice A into D2, and shear strength of the rod end is equals to twice A into D2 into tau. Equating this load P with, we have P is equals to twice A into D2 into tau. So from this equation, the distance from the end of the slot to the end of the rod, that is A. See guys, from this equation, what we get, the distance from the end of the slot, okay, to the end of the rod, that is which is denoted by small a, may be obtained. So by this step number 8, we are going to get this dimension. This is step number 9. Please see what step number 9 tells us: the failure of spigot collar in crushing. See guys, failure of spigot collar in crushing. So considering the failure of spigot collar in crushing as shown in figure, this is a failure of spigot collar in crushing. We know that area resist crushing of the collar is equals to pi by 4 into d3 square minus d2 square, and crushing strength of collar is equals to pi by 4 into d3 square minus d2 square into sigma c. So equating this to load P, we have P is equals to pi by 4 into d3 square minus d2 square into sigma c. So from this equation, the diameter of the spigot collar d3 may be obtained. So see guys, these are the various 9 steps of socket and spigot collar joint, and by this step number 9, that is by considering spigot collar in crushing failure, we get this dimension, that is diameter of spigot collar, that is d3 is obtained. Now what next? So this is step number 10. What it is in step number 10? Failure of the spigot collar in shearing. See guys, failure of the spigot collar in shearing. Considering the failure of spigot collar in shearing as shown in figure, we know that the area that resists shearing of the collar is equals to pi into d2 into t1, and shearing strength of collar is equals to pi into d2 into t1 into tau. So similarly, as we have seen in the last 9 steps, we need to equate these relations with the load P. Then we left with the pi, P is equals to pi into d2 into t1 into tau. And from this equation, the thickness of the spigot collar t1 may be obtained. See guys, thickness of the spigot collar T1 may be obtained. Okay, so in this way all these 10 steps we have successfully completed, and all these 10 steps, if you uh, design a quarter joint, or if you solve any numerical based on the quarter joint by considering these 10 steps, then that will make complete justice with the design of quarter joint. There is no need to do additional design, because these 10 steps are more than sufficient. And if you ask in examination to write the design procedure of quarter joint, then you need to uh, what we say, you need to write all these 10 steps with the all the dimensions and all the formulas. Okay, so I think this content is beneficial for you guys. So we are going to meet again with new content and all. So thank you very much.